Have you ever gazed up at the night sky and wondered if humanity could truly live among the stars? Not just visiting, but building permanent homes in the vastness of space. It sounds like science fiction, but it's a future that scientists and engineers are working on right now. This isn't just about planting a flag on another planet. It's about creating self-sustaining worlds, entire ecosystems floating in the cosmos. Welcome to the incredible world of space habitats. So, why would we even need to build homes in space? Well, for a few big reasons. First, it's about survival. Having humanity spread across multiple celestial bodies is the ultimate insurance policy against any catastrophe that might strike Earth. Think of it as not keeping all our eggs in one basket. Second, it opens up a new frontier for exploration and science. Living in space gives us a permanent base to study the universe, mine resources from asteroids, and push the boundaries of technology. And finally, there's the sheer spirit of adventure. It's in our nature to explore, to see what's over the next hill, or in this case, the next planet. When you think of a space habitat, you might picture a simple, cramped station like the ISS, but the concepts on the drawing board are far grander. Let's start with one of the most famous ideas, the O'Neill cylinder. Imagine a pair of massive cylinders, each several miles long, rotating in space. This rotation creates artificial gravity through centrifugal force, so you could walk around inside just like you do on Earth. The inner surface would be landscaped with towns, forests, rivers, and farms, all illuminated by sunlight directed inside by giant mirrors. It would be a complete self-contained world for millions of people. Another fascinating concept is the Stanford Torus. Picture a giant spinning donut about a mile in diameter. The donut itself is a tube where people would live, work, and play. Just like the O'Neill cylinder, the rotation provides Earth-like gravity. The interior would be a continuous ring of habitable land with a sky above that's actually the other side of the ring. Sunlight would be bounced in with a system of mirrors, creating a regular day and night cycle. These designs aren't just about providing shelter. They're about creating a comfortable and psychologically healthy environment for long-term living. Then there's the Bernal sphere, a slightly different take. This would be a smaller spherical habitat, perhaps a mile in circumference. The population would live along the equator of the sphere's interior, where rotation creates the gravity. The poles of the sphere would be zero-gravity zones, perfect for recreation, specialized manufacturing, or docking spacecraft. The idea is to create different zones for different purposes, all within one structure. Huge windows would let in natural sunlight, making the interior feel open and connected to the cosmos outside. Of course, building any of these structures is a monumental challenge. First, where do we get the materials? Launching millions of tons of steel, soil, and water from Earth would be incredibly expensive and impractical. The solution? Use resources already in space. We could mine the moon or nearby asteroids for raw materials like iron, nickel, silicon, and aluminum. We could even harvest water ice from these bodies. Using space-based resources is the key to making large-scale construction feasible. This concept is called in situ resource utilization, and it's a cornerstone of future space exploration. Once we have the materials, how do we build? We'd likely use advanced robotics and 3D printing on a massive scale. Fleets of automated construction bots could assemble the habitat's framework piece by piece in orbit, far from the constraints of Earth's gravity. It's a bit like building a ship in a bottle, but the bottle is the vacuum of space, and the ship is an entire world. But a habitat is more than just its structure. It needs a functioning ecosystem. How do we create a breathable atmosphere, clean water, and a sustainable food supply for thousands or even millions of people? This is where closed-loop life support systems come in. Think of it as a miniature Earth biosphere. Plants would be grown hydroponically or aeroponically, not just for food, but also to produce oxygen and recycle carbon dioxide. Water would be rigorously recycled and purified, with every drop being reused. All waste, both human and agricultural, would be broken down and converted back into nutrients for the plants, creating a perfectly balanced, Self-sustaining ecosystem that can run for decades or centuries without resupply from Earth is one of the biggest, most complex challenges we face. And what about protecting a habitat from the harsh realities of space? Out there, you have to deal with cosmic radiation, micrometeoroid impacts, and extreme temperature swings. Habitats would need thick, robust shielding. For O'Neill cylinders and Stanford toruses, a thick layer of rock and soil mined from the moon or asteroids could serve as excellent radiation shielding, while also providing the land for agriculture and settlement. Advanced sensor systems would constantly scan for potential impact threats, allowing the habitat to maneuver or deploy defenses. Let's imagine what life would be like inside one of these marbles. You might wake up in your apartment with a view of Earth or a distant nebula. You'd walk to work or school under a blue artificial sky. The gravity would feel completely normal. You could go for a hike in a forest, swim in a river, or play sports in a park, all inside this giant rotating structure. But you'd also have unique opportunities. You could take a trip to the zero-gravity core of the habitat for a game of 3D soccer or to simply float and relax. The view of the stars, unfiltered by an atmosphere, would be a constant, breathtaking reminder of where you are. These habitats could become hubs of a new spaced economy. Industries that are difficult or impossible on Earth, like manufacturing perfect crystals in zero gravity or assembling massive spacecraft, would thrive. They would be gateways to the solar system, serving as way stations for missions to Mars, the asteroid belt, and beyond. They would be cultural melting pots, where people from all over Earth come together to build a new branch of human civilization. This vision isn't just a dream. Organizations like NASA and private companies are already developing the foundational technologies needed to make it happen. We're learning how to mine asteroids, 3D print in a vacuum, and create more efficient life support systems. The International Space Station is our current laboratory for understanding how humans adapt to long-duration spaceflight. Every mission, every experiment, is a small step toward the day we build our first permanent home beyond Earth. The journey will be long and filled with challenges we can't even predict yet. But the potential reward is immeasurable. A future where humanity is not confined to a single planet, but is a true spacefaring civilization, with a presence across the solar system. The dream of living in space is one of the most powerful drivers of innovation and exploration. It forces us to think bigger, to solve harder problems, and to work together on a global scale.